So you've all seen solving a system by substitution at least a little bit. But now I'm going to give you 4 examples of me in a video. Oh, I didn't finish filling this one out. Actually, I can kind of show you the way that I create the examples. So these weren't problems I got from anywhere. I made them up. But I need to pick a solution. So I'm going to pick the solution in my head. -3, -3, 1. So -3. So that would make that. If I do -3, 1. And if I do this as -3, 1, -15 plus 1, this should work out. And we should be able to solve that and get -3, 1. But anyway, when you're solving a system of equations by substitution, you're looking to make sure that one of the variables, either x or y, in either equation is isolated. So you can see that looking at this has a coefficient of 3, that has a coefficient of 4, that has a coefficient of -2, and this one right here is by itself. So it will make sense for us to kind of highlight this one. I'm not highlighting, I'm writing it in red, and let's get that by itself. So I'm going to add 2x to this side, and I'm going to get that y by itself. It doesn't matter what form I write this in. One thing I always do after I isolate it is I put it kind of in this cloud shape, because we are going to be substituting -11 plus 2x in for y in the other equation. So this is going to replace that y. That's why we call it substitution. So I'm going to write that top equation. I'm going to write it exactly as it says, except instead of writing y, I'm going to replace it with the -11 plus 2x. So that's what I have there. Then I'm going to proceed and I'm going to solve it like normal. I have just x's, so this should be pretty quick solving. Some of you are better at it than others, but you're all familiar with it. Make sure I don't make any little errors here. So 3x plus 8x. I've got the -44 equals 66. Timeout, guys. I'm not going anywhere. But Avery, do not throw that picture away. That is remarkable.
It's not.
Okay, thank you. Sorry, guys.
How much longer?
Yeah, about 6 minutes.
Sorry for interrupting.
That's okay.
And 6 minutes longer?
Yeah, 6 minutes longer. You'll see.
It's short. Oh my god.
It is short. They're wishing it was shorter right now.
Okay.
Anyway, so x equals 6. The reason the cloud helps us is when you get distracted along the way by perhaps small children in the room or,
Shut up, Mom.
sorry, a barking dog.
You're not helping me.
It brings you right back to the cloud. So if you know x equals 6, well, we can plug it in there because we know y equals -11 plus 2 times 6. So I get y equals 1 out of that. So my answer to this is 6, 1. What that means is if you went to graph it, that system of equations would intersect at the point 6, 1. So I will do this one a little quicker just to make my son happy. So x is by itself. It's going to be the easiest one to solve for. So I'm going to add 3y. So I'm going to do that. So now I have the equation x equals
Interrupting kid.
-6 plus 3y. So if x equals that, I'm going to plug it in for x. So I have 5 times my new x, which is that,
Your new x.
plus 3y
New next.
equals -12. So I have -30 plus 15y plus 3y equals -12. So I have 18y equals, when I add that over I get 18, so y equals 1. I like to sometimes write it right in the ordered pair so I don't forget to solve for x. Well, remember x equals -6 plus 3y. And I now know y equals 1. So I get -3. So if we were to graph these two lines, that's where they would intersect. This one here, y is isolated in both of them. So if I just place a cloud around that one, let's substitute it in for the other y. So you end up with an equation where, since they both equal y, they equal each other. So 4x plus 2 equals negative 2x minus 2. So I am going to add 2x. I'm going to subtract 2. And I get negative 2/3. Not ideal. I know we don't love fractions, but I do. Then there's our y that we have to solve for. You can pick either equation. I'm just going to pick the top one. So y equals 4x plus 2 plus 2. So I get negative 8/3 plus 2, which I know is like negative 8/3 plus 6/3, which is negative 2/3. So that's where they would intersect. Not at a perfect point on the coordinate plane, but it's close. And lastly, I can automatically see that this x is going to be the easiest one to isolate. So I've got that by itself, and I'm going to substitute it back in. Oops, that's supposed to be pointed at the x. I overaimed. So I've got 2 times my x minus 4y. What you should see is you should see something weird happening.
How?
Those are canceling, and you get a false statement. If it's false, it's no solution. If it were true, it would be infinitely many solutions, which would mean it would be one line. You might have noticed at the beginning that the top equation was twice as big as the bottom equation in terms of the x's, but not quite this. There was a sign that was off, so that's why it's no solution. If this were a positive 5, it would have been infinitely many. Hope that helps.